What if the safest code is the code you never write? That's the rule of zero. Let's get started. Hey, welcome back. Coffee ready? Perfect. Welcome to the Clean Code C++ series, where coding meets comfort. Have you ever had a C++ program suddenly crash out of nowhere and you're left wondering what went wrong? Today I'm going to show you a powerful modern C++ principle called the rule of zero that'll end these frustrating surprises once and for all. Now, let's start by looking at an example. Imagine you're creating a simple class to hold a user's profile. You decide to handle the memory for the username yourself using a classic C-style string, just a basic character pointer. You might end up writing code similar to what's on the screen now. So let's walk through this together step by step. In our user profile class, the constructor is taking a name provided as a C-style string. And here's what's going on. It allocates exactly enough memory on the heap to store that name using the new keyword. This part is absolutely key because we are now manually managing this piece of memory ourselves. Since we used new, we obviously know we have to clean it up. That's why we wrote a destructor. Its whole job is to simply free the memory that we allocated earlier by calling delete on that memory. At first glance, it seems like we're doing everything responsibly. Memory gets allocated, and later it's deallocated. Everything seems good. But here's where the disaster is waiting to happen. Right in our main function. We create our user1 with the name Alex. Then immediately afterward, we create user2 by making a copy of user1. Now, this one simple line of code is a ticking time bomb. If you run this code, you might not immediately see an error, or your program might crash in a really nasty way. Why is that happening? Well, because when you copied user1 to create user2, the compiler tried to help you by generating a default copy constructor. But here's the catch. This default copy is what's known as a shallow copy. It literally just copies the pointer itself. This means both user1 and user2 now point to the exact same location in memory. And this is where the problem starts. When main ends, user2 gets destroyed first. Its destructor runs and frees the memory with delete. But right afterward, user1 is destroyed, and it also tries to delete that same piece of memory again. This is known as a double free, and its undefined behavior, your program is likely to crash horribly. You created this mess because you're manually managing resources but haven't instructed the compiler how to handle copies properly. This scenario is a classic violation of what's called the rule of three, which says if you write a destructor, you almost always need to write your own copy constructor and copy assignment operator as well. But there's an even better, cleaner solution available, and that's the rule of zero. So how do we fix this mess and write clean, safe, professional level code? Here's the solution. We'll let the C++ standard library to do the heavy lifting for us. We follow the rule of zero, which says that your goal should always be to write zero special member functions. That means you shouldn't be writing your own destructors, copy constructors, or assignment operators. Now, let's rewrite our user profile class using this approach. Just look at how much cleaner and shorter this version of our code is. In this rewritten class, we have replaced our row pointer, the char pointer, with a string. The standard string class from the C++ library is an amazing tool because it manages its own memory for you. When you create a string, it allocates memory automatically. When you copy that string, it handles creating a completely new copy of data for you. And most importantly, when the string object gets destroyed, it automatically cleans up the memory it allocated. This powerful technique is called RAII, Resource Acquisition is Initialization. It simply means that a resource lifetime is tied directly to the lifetime of the object that holds it. Notice what's missing from our new version of the class. There's no destructor. There's no copy constructor. We didn't have to write any of those things. We followed the rule of zero. Now, when we go back to our main function and write user profile user2 equals user1, everything just works perfectly. The compiler generated copy constructor sees the string member and automatically calls its own copy constructor. The string knows exactly what to do. It creates an independent copy of the username data for user2. There's no shared memory, no double free, and certainly no crashes. This code is safer, easier to read, and clearly communicates exactly what it's doing. That wraps up it for today, but there's way more where that come from. Head to alcoacademy.com for my full masterclass and check out more cool tutorials on my channel. Don't forget to like and comment, it truly means a lot.